All right, welcome to our next lesson. This is actually the last new piece of learning we're going to be going over before we take our tests on Friday. So we are staying with the same standard as before, 8 and S1, and we are now really getting into the meat of this, knowing that numbers that are not rational are called irrational, and we're going to be working with that today. So by the end of this lesson, you'll be able to classify numbers as either rational or irrational. You'll know you're successful when you can classify a number as rational or irrational, as well as determine if the decimal is terminating, repeating, or if a number is considered a counting number. So we're just really going to classify our numbers today, okay? We're going to get into this work right now. All right, so on this page, I do want you to write down what I write. We're just going to build some background knowledge about this lesson before we get into the real meat of the work today. So I want to go over what some of these terms mean because we're going to be classifying our numbers today. So counting numbers are the numbers that you start off learning to count when you're a little kid, like 1, 2, 3, 4, 5, etc. We don't start with 0. 0 is not a counting number. So if I gave you the answer or the representation of the square root of 16, this is a counting number. And the reason why this is a counting number is because this equals 4. Okay? The next we have terminating decimal. So a terminating decimal is a decimal that does not repeat, but it does end. Okay? So, for example, I could give you the number 4.22. That's a terminating decimal. It ends. Okay? There is no repeating sign over those 22s, or the 2, even though it's the same number back to back. It is not saying that it's going to keep saying 2, 2, 2 forever. So this is a terminating decimal. Another example of a terminating decimal might be 5.0138. Super long, right? But it stops. It ends. So those are both examples of terminating decimals. Okay? A non-terminating decimal below is a decimal that does not end. And I'll add some stuff off to the right. So this is a number that goes on forever and we cannot find a pattern for it. And usually it's denoted by these 3 ellipses, dots at the end of it, okay? So we can't find a pattern for it. It just keeps on going and going. We can't predict what comes next. There's no repetition going on with it. Another example of this would be our famous number of pi. We represent this as 3.14, but honestly, it goes on forever, and there's never a pattern. It does not terminate, it does not end, it doesn't repeat. Okay? Next up, we have a repeating decimal. So repeating decimals, there is a pattern in them. So if I have that and it just keeps saying 2, 3, 2, 3 forever, I can put a line over my 2, 3, and I know that it's going to keep doing that forever and ever and ever. Okay? Additionally, I could have a number like 1.1 with a little repeating sign over it. It could be that short and simple. But if there is a repetition, we denote that with a little line over top of the numbers that do repeat. Okay? So a rational number and an irrational number, these are big definitions for today. Okay? Rational number and irrational number. So please make sure you're listening to this next part and you're getting this down because you will use it throughout the lesson and it will definitely be on your test. So an irrational number is a number that you know what, a rational number, that's what I'm starting off with, rational, is something that you know what comes next. It can be predicted. So the rational numbers here are terminating decimals. These are rational. Counting numbers are rational. Repeating decimals are rational. Everything I just highlighted in yellow, those are all rational numbers. So I'm just going to give you a few more examples down here. If I had 12 over 3, this is a rational number because this equals 4. If I had the square root of 25, this is a rational number because it equals 5. If I had 7.2934 with a 3, 4 repeating, that's a rational number because I know what comes next. If I had 1.25, that's a rational number because it ends. So I know what comes next. So counting numbers, terminating decimals, repeating decimals, if we can predict what's going to come next, then it is a rational number. Okay? Irrational numbers, we cannot be predicting what comes next. They go on forever, and there is no pattern. So these are non-terminating decimals. They never end. We can't predict what comes next. So an example of an irrational number is the square root of 2. So if you were to put that into your calculator, it's just going to go on forever and ever and ever and ever. Pi is an irrational number. Okay, and I could write another one down here. Maybe I put 1.56312 dot dot dot. That dot 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 tells me that it goes on forever, and there's no pattern that is recognizable. So this is the difference between rational and irrational number. Rational, we can predict. Irrational, we don't know what comes next. Okay, we're going to get into our work now, classifying our numbers. All right, for example number 1, we want to classify this number. I know it's a little bit weird looking right now, but it's 0.692. 0.692. And we want to classify this as the things off to the right. So is this a counting number? No. This is not a counting number, because remember, counting numbers are 1, 2, 3, 4, 5, all the way up. Is this a terminating decimal? Does it end? Well, I don't have anything saying that it's going on forever. There's no dot dot dot, and there's no line over top indicating a pattern. So yes, this is a terminating decimal. It ended right there at the 2. Is it a non-terminating decimal? Well, if it's terminating decimal, it's not a non-terminating decimal. So it doesn't go on forever. Does it repeat? Nope, there's no repeating sign over any of the numbers. So the last one I want to determine, is it rational or irrational? So rational means I can predict what comes next. Irrational means I can't predict it. So for this one, 0.692, if I were going to add a decimal that comes after this, I know that what comes next is a 0. And it's just going to keep being a 0 forever. I can always predict that's going to come next because it stopped right here. Okay, so I can predict what comes next. Is it unpredictable? No, it's not unpredictable. So this is what this number is classified as. It's a terminating decimal, which means it's a rational number. We can predict what comes next because it ends right there. It's very predictable. Okay? All right, moving on to the next slide. All right, example number 2. We have the square root of 28. Now the square root of 28, I can break this down. Okay, this is the same. The square root of 4 times 7. And I can actually take the square root of this 4. This becomes 2 root 7. So 2 times the square root of 7. So I'm going to classify it off to the side based on what I know about this number. So, is this a counting number? No, this is not a counting number. This is 2 times the square root of 7. Is it a terminating decimal? Well, I would have to figure this out in my calculator, and I would have to do this math. So the square root of 7, that is not going to be a rational number. That's going to be a decimal that continues to go on forever. 7 is a prime number, so it's going to go on forever. It's not going to terminate, so it's not going to be a terminating decimal. So yes, it is non-terminating. It goes on forever. Okay? Does it repeat? Nope, it has no repetition. And if it doesn't repeat and we can't predict what comes next, it is not rational, it is irrational. So this number is a non-terminating, irrational number. And I want to just let you guys know, if you really wanted to figure out what this number looks like in your calculator, you can put this into your calculator. I'm going to show you pretty soon how to plug in that radical sign to your calculator so we can find the square root of 7. And you'll see that it goes on forever. There's no pattern. And so even if we were to take that and then multiply it by 2, there's not going to be anything we can predict. It's going to stay an irrational number. So this is an irrational number. It's a non-terminating decimal. Okay? Moving on to example number 3. All right, for example number 3, we have 0.4 divided by 0.8. Now, if I were to do this in my calculator, or to even do it out by hand, or even see, I can see that this is 1/2. 4 is half of 8, and 0.4 is half of 0.8. So this is the same as saying 0.5 when we do that math. Okay? Is this a counting number? No. That is a decimal. Does it terminate? Does it end? Yes, it is a terminating decimal. So it does end. It's not non-terminating. Does it repeat? No, it's not a repeating decimal. It just stops at 0.5. So is this a rational number or an irrational number? Can I predict what comes next? Yeah, I could add a 0 there. I could predict what's going to come next. I can add as many zeros as I want. This is a rational number. It's not irrational. Okay? So 0.4 over 0.8 is a terminating decimal that is a rational number. Go ahead and make sure you have this down. We're going to move on to the next one. All right, so again, our new learning for today, we have counting numbers like 1, 2, 3, 4, 5, etc. So I told you this earlier, but the square root of 16 will be 4. So this is a counting number. Terminating decimals are decimals that end. 5.2, that ends. Okay. 3.01, that stopped right there. There's no repeating sign. There's no forever ellipsis sign. Non-terminating decimal, this would be something like 5.231 dot dot dot. It goes on forever. Another example of this is pi. Repeating decimal, this is a decimal that has a pattern. So even if I took what I had before and put a line over top, that shows me that there's a pattern there and I can predict what comes next. Rational numbers are numbers that we can predict. Okay, and I'm going to highlight those that we just did in blue. So rational numbers are counting numbers. They are terminating decimals. And they are decimals that have a pattern. So everything that I just put in blue is a rational number. And irrational numbers are numbers that do not end and don't repeat. I just highlighted some of our irrational numbers in green. Okay, this is our new learning for today, just classifying numbers. Based on these things, we're going to move forward into some practice now. All right, I want you to go ahead and try this one on your own. It is pi take away 1. So I'm going to help you out a little bit here. 3.14 dot 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 minus 1. So this is going to be 2.14 dot dot dot. Goes on forever. We don't know what comes next. So go ahead and classify that as the things off to the right side, and we're going to go over it in about 30 seconds. Okay? All right. 2.14 dot dot dot. I don't know what comes next. This is not a counting number. This is not a terminating decimal. This is a non-terminating decimal. That means it doesn't end. It goes on forever. You can see the ellipses at the end, the dot dot dot. Does it repeat? Nope. So is it rational? Nope. It is irrational. So the two that you should have selected here were irrational and non-terminating. It goes on forever. All right? If you have any questions here, let me know. But if you don't, we're going to move forward to the next one. All right, next one, you have 0.32 repeating. So go ahead and look at this number. Sorry, it's negative 0.32 repeating. And classify it off to the side with your list. We're going to go over in about 30 seconds. All right, this is not a counting number because this is a decimal. This is a terminating, this is not a terminating decimal because it has the repeating sign. So it repeats. So this is a non-terminating decimal and a repeating decimal. Now, is this rational or irrational? Well, it might be split because someone might say, well, it repeats, so we can predict it. Someone might say, well, it never ends, so we never know what's going to happen. But if it repeats, we do know what's going to happen next. So it is rational. It is not irrational. We can predict what comes next. So this is a non-terminating, doesn't end, repeating, has that repeating line over top, rational number. Okay, make sure you have those down. And we're going to move forward. All right, this next one you have negative 3 plus the square root, or plus pi. So we have negative 3 plus 3.14 dot dot dot. It goes on forever. So go ahead and think about this. And we will go over it in about 30 seconds after you mark your boxes to the right with what you believe it should be classified as. All right, so when we take a negative 3 and we add it to positive 3.14, repeating or going on forever, this is the same as saying 0.14 ... forever. And I did that because I took away 3 whole numbers from this right here. Okay, so that became a 0. It still is going on forever because it's pi. We can't predict what comes next. So off to the side, we're going to make our selections. This is not a counting number. This is not a terminating decimal. So this is non-terminating. It does not repeat. It is not rational. It is irrational. Okay, so please go ahead and make your selections. Match them with mine. Ask me questions if you have any questions. If you got something different, let me know and we can talk about it and why that shouldn't be or should be. Okay, and we're going to go ahead and move into the next slide. All right, for exercise 5, you have this number off to the side, 0.5555. Okay, let me know what you think it is, and we're going to go over it in about 30 seconds. All right, so obviously this is not a counting number, it's a decimal. Does it terminate? Does it end? Yeah, it ends right here. This is the end of my decimal, so it does terminate. That means it's not a non-terminating decimal. Does it repeat? Well, you might look at that and say, yeah, it does repeat. There's a bunch of 5s. But the answer is no. There's no repeating sign up here. Okay? There has to be a repeating sign over top of the numbers for you to know that it's going to repeat. Otherwise, you cannot assume that. This is a rational number because it does end. We can predict that after this 5, if we wanted to add on numbers, they would all just be zeros. Okay? And so that is not irrational. So the correct answers that you should have selected here were that it is a terminating rational number. Okay, let me know if you have any questions, and then we will move forward. All right, just to review our learning for today, counting numbers are numbers like 1, 2, 3, 4, 5. They're whole numbers. We don't start with 0 though. Okay, terminating decimals are decimals that do not repeat, they just end. Non-terminating decimal are decimals that do not end. Repeating decimal are decimals that repeat in a pattern. These are also non-terminating because they just repeat, they don't stop. Okay? Rational numbers are numbers that can be predicted. And irrational numbers are numbers that cannot be predicted. And you have your list of those down below. Counting numbers, terminating decimals, and repeating decimals, and then non-terminating decimals and non-repeating decimals here. Okay, we're going to move into our exit ticket now. All right, for your exit ticket today, you're going to go through these numbers and you're just going to check off what they represent. So for example, if you thought that was that, and that, you would do that. Okay, for each row, you're going to let me know how you want to classify them. I'm just randomly selecting these, so do not put these down as your answer right now. But you're just going to classify these numbers that you see. Okay, if you have trouble, if you need help, go back through, rewatch some of these examples and exercises. And then when you're done with this, go ahead and complete your lesson reflection in Google Classroom, okay?